Hi everyone. So in today's video, we're going to start the Chapter 6 section of our Module 3, Chemical Bonding. All right, so previously we talked about electrons and where electrons exist around a nucleus. And now we're going to look at how electrons are used to form chemical bonds. So we're going to talk about different types of compounds. And remember, compounds contain two or more different elements. All right, so first let's talk about ions, because ions form our first type of chemical bond, which is an ionic bond. So atoms lose, gain, or share electrons to acquire an octet of 8 valence electrons. So remember last time at the very end of the video, I mentioned that atoms want to either lose electrons to become like a noble gas, or they want to gain electrons to become like a noble gas. So one other option is atoms can share electrons to become like a noble gas. So remember, noble gases are in group 8A, which means they have 8 valence electrons, or 8 electrons in the outermost energy shell. And noble gases are really stable, so all atoms want to become stable. So they want to end up with 8 valence electrons, or an octet of electrons. All right, so let's talk about the two types of bonds before we kind of go into ions a little bit more. So ionic bonds occur when valence electrons of a metal atom are transferred to the atom of a nonmetal. So you might recall from our previous discussion that metals tend to lose electrons and nonmetals tend to gain electrons. So we can use that to our advantage and form ionic bonds. Okay, so ionic bonds occur between a metal and a nonmetal. Also, remember that the majority of elements are metals, and only that upper right-hand corner of the periodic table consist of nonmetals. So there are very few nonmetals. All right, and then covalent bonds occur when nonmetal atoms share electrons to attain a noble gas arrangement. So covalent bonds occur between a nonmetal and another nonmetal. And remember that nonmetal atoms would want to gain electrons. So if we have two nonmetal atoms bonded together, they can't really transfer electrons because they both want to gain electrons. So instead, they're going to share their electrons. And here's a diagram showing both types of bonds. So we have an ionic bond on the left and a covalent bond on the right. So if we just look at the ionic bonds, M stands for metal, and then NM stands for nonmetal. So the metal is giving an electron over to the nonmetal, and when that happens, the metal becomes positively charged, and the nonmetal becomes negatively charged. So remember, the metal atom is losing an electron which has a negative charge. So what we end up with at the end is an excess of protons. So the number of protons no longer equals the number of electrons. We have one less negative charge, which means we have an overall positive charge. So for example, let's say that metal atom is lithium. And we said that lithium has 3 protons and 3 electrons when it is neutral. But what if it loses one of its electrons? So let's say now it has 2 electrons. So we can see that 2 of the positive charges will cancel out. So let's say we kind of write it out like this. Initially, we had 3 positive charges and 3 negative charges, and they all canceled. But if we get rid of one of the negative charges, now we have an overall positive charge on that metal atom. All right, so now the nonmetal is going to become negatively charged because it's gained an electron. So kind of similar to what we said before, now we no longer have equal amounts of protons and electrons. So if we have one more electron, that makes the whole atom negative. And then on the right-hand side, we have a covalent bond between 2 nonmetal atoms. So the nonmetal atoms here each have 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7, and it's the same on the other nonmetal atom as well. But remember that all atoms want to be like a noble gas, so they want 8 total electrons. However, we just said nonmetals can't give each other electrons because they both want to gain electrons. So instead, they're just going to share their 2 unpaired electrons here, and they're going to just create a shared bond there. So what we can do is count the number of electrons individually for each atom. So the nonmetal on the left has 2, 4, 6, 8 electrons, and the nonmetal on the right also has 2, 4, 6, 8 electrons. So they are both happy. Okay, so these are the 2 types of bonds that can form in compounds. Okay, so now let's talk about ions a little bit more. We're going to talk about positive ions. So we just said that that involves a loss of electrons. So in ionic bonding, ions form when atoms gain or lose their valence electrons to form a stable electron configuration, so a noble gas configuration. So in group 1A, group 2A, and group 3A, we have metals. And metals have low ionization energies, so that means it's really easy to lose electrons. So they don't need a lot of energy in order to lose their electrons. So when they lose one of their electrons, they form a positive charge. Now, some metals can actually lose more than one electron, so we'll talk about that later as well. Now, metals are going to lose enough electrons in order to have the same number of valence electrons as the nearest noble gas. So that's usually 8 electrons, although remember, helium has only 2 electrons. So that's our exception. Okay, so if we do end up with a positively charged ion, we call that a cation. And we just name that ion according to the name of the element. We'll see that in other cases we're going to change the name slightly. All right, now if you have trouble remembering what a cation is, just think of a cat. and it is positively charged. So that's a good way to remember what a cation is. It's a positive ion. Okay, so let's look at an example of a positive ion. We're going to look at the example of sodium. So sodium is in group 1A, so they have, so sodium atoms have one valence electron and a total of 11 electrons. All right, so if sodium loses its one valence electron, it's going to end up with only 10 electrons total. However, the number of protons or positively charged subatomic particles does not change. So in our final ion here, we have 11 protons after, 11 protons and then 10 electrons after losing an electron. So the ratio between protons and electrons has changed, and we have one extra positive charge. So we now have a positive sodium ion. Now also, let's look at the electron configuration for the neutral atom versus the positive ion. So in the neutral atom, with 11 electrons, the configuration is 1s2, 2s2, 2p6, 3s1. But notice we're losing that last electron there in the highest energy level. So the final electron configuration after losing that one electron is 1s2, 2s2, 2p6. Now also notice that the highest energy electrons are in energy level 2, and there's 8 of them. So we've got 2 plus 6, that's 8 valence electrons. So now sodium is happy. Sodium has 8 valence electrons, and its electron configuration is the same as that of neon. So it's like a noble gas. Okay. Now let's look at magnesium. Magnesium is in group 2A, so it has 2 valence electrons. So typically a neutral magnesium atom will exist with 12 electrons and 12 protons. But remember that all atoms want to become like a noble gas. So in order to do that, magnesium is going to lose 2 electrons. And when it loses those 2 valence electrons, it ends up with only 10 electrons. But magnesium still has 12 protons, so its charge will be 2 plus. Now that's always going to be true for magnesium. It will always lose those 2 valence electrons to become like a noble gas. Okay, so let's look at the electron configuration for neutral magnesium. It's 1s2, 2s2, 2p6, 3s2. And so we've got our 2 valence electrons there in energy level 3. And then once magnesium loses those 2 electrons, we end up with an electron configuration of 1s2, 2s2, 2p6. And this probably sounds familiar because it's the same as neon's electron configuration. So now magnesium is much more stable with a 2 plus charge. Now what about nonmetals? Because remember, in an ionic bond, we have a metal and a nonmetal atom. So in nonmetals, which are in groups 5A, 6A, and 7A, we have really high ionization energies, which means that it's difficult to lose electrons. So instead, nonmetals are going to gain one or more valence electrons, so gaining electrons, to form ions with a negative charge. So nonmetals are going to gain electrons until they have the same number of valence electrons as the nearest noble gas. So that's usually 8 valence electrons, except, again, for helium, which only has 2. Okay, so if we end up with a negatively charged ion, we call that an anion. And I don't really have a good way to remember that one, but as long as you know that there are cations and anions, cations are positively charged. All right, so when we're naming negative ions, we use the first syllable of the element name, and then we add IDE to the end, which is kind of strange, but you'll get used to it as we go along and get some practice. So, for example, if nitrogen becomes negatively charged, we would call that nitride. If oxygen becomes negatively charged, we call that oxide. And then let's say fluoride becomes negatively charged. We call that fluoride. And you might have heard of fluoride because that's what's in toothpaste and water, and it helps prevent cavities. So those are actually fluorine ions or fluoride ions. All right, so let's look at an example of a negative ion. We're going to look at chlorine, which is in group 7A. So that means they have 7 valence electrons. And so chlorine with 7 valence electrons only needs to gain 1 more electron to have a total of 8, like a noble gas. So down below, you can see we have a neutral chlorine atom, and it's going to gain an electron. And when that happens, we will end up with 18 electrons. However, chlorine's number of protons never changes, so we still only have 17 protons. So now we have an extra electron, which means chlorine will be negatively charged. All right, so let's look at the electron configuration for the neutral atom. We have 1s2, 2s2, 2p6, 3s2, 3p5. Once chlorine gains an electron, the end of this will be 3p6. And this is actually the same as the electron configuration for argon, which is a noble gas. But additionally, if we highlight the highest energy electrons there, we have 2 plus 6, which is 8 valence electrons. So the chloride ion is much more stable with that extra electron. Okay, so now let's kind of summarize what we've gone over. And in your textbook, there's a table 6.3, and this really shows how you can remember the charges for different ions. All right, so in the first column here, let me change my marker here. So in the first column there, we have noble gases, because remember, that's what all of these atoms want to become like. So they want to be noble gases in a sense, or at least have the same electron configuration as a noble gas. So lithium, to start, remember, is in group 1A, and it has 1 valence electron. If it loses that 1 valence electron, it becomes like helium. And as we go down this first column, you can see that everything in that column is a group 1A element. and they're all going to have one valence electron. So that means each of those atoms can lose one electron to become like a noble gas. So if you're trying to remember the charge for a metal ion, you can just go off of the group numbers up above. So group 1A metals will all lose one electron to have a +1 charge. And then as we go down group 2A, you'll notice they all have a 2+ charge. So all of those atoms have 2 valence electrons that they can lose to become like a noble gas. So they're all going to have a 2+ charge, which matches the group number. And then in group 3A, we just have aluminum as our metal that has a predictable charge. Everything else in that group doesn't really have a predictable charge, so we're just only going to include aluminum here. So aluminum has 3 valence electrons that it can lose to become like a noble gas, so it will have a 3+ charge. Now, it gets a little bit tricky when we go to the nonmetals because their charges do not match the group numbers up above. So for instance, in group 5A, nitrogen and phosphorus have 3- charges. And that does not match the group number. So the other way to remember this is to subtract the group number from 8. So 8 minus 5 is 3. And that's our charge. Now, if we look at group 6A, we have oxygen, sulfur, and selenium, and they all have a 2- charge. So that means they all gain 2 electrons to become like a noble gas. And so again, we can say 8 minus 6 is equal to 2, and that's our negative charge. And then group 7A, we can do the same thing. 8 minus 7 is 1. So each of the group 7A elements gains 1 electron to end up with a -1 charge. Now, you'll notice that group 4A is missing from this chart, and that's because the group 4A elements tend to form covalent bonds, not ionic bonds. So we're just not including them here, but we'll talk about them later. Now, ions are really important in order to regulate our body functions. So you might remember that sodium and potassium are highly explosive, very reactive with water. But that's when they're in their neutral forms. Now, in their ionic forms, they're much more stable, and so they're not going to react violently anymore. So when you hear that you have sodium ions and potassium ions, don't worry, they're not explosive. They are perfectly fine as ions. And it's a good thing that we don't have pure sodium and pure potassium in our bodies because we are made mostly of water, so that would not end well. All right, so sodium and potassium ions are really important for regulating cellular functions. And you can find those ions in things like bananas, salt, cheese, milk, etc. And then calcium ions are also really important. They are found in our bones, and that's what keeps our bones really strong. So you can find calcium in milk, yogurt, cheese, a lot of dairy products. And then magnesium is really important as well in bones, but also it's found outside of cells, and it's essential for our muscles and nerve control. And so magnesium ions you can find in nuts and grains. Okay, so let's do a learning check. Let's consider the elements calcium and chlorine. And we're going to identify them as either metals or nonmetals. We're going to state the number of valence electrons for each. And then we're going to state the number of electrons that must be lost or gained for each of them to acquire an octet, or 8 electrons. And then we'll write the symbol for the ion, and we'll name them too. So if you want to try this on your own first, feel free, and when you unpause the video, we'll go over it together. Okay, so let's start with calcium. So is calcium a metal or a non-metal? So calcium is on the left-hand side of the periodic table in group 2A, so it is a metal. In fact, it's an alkaline earth metal. So how many valence electrons does calcium have? So it's in group 2A, so it has 2 valence electrons. Okay, so how many electrons does calcium need to lose or gain to acquire an octet? So I guess the first question here is really, will calcium lose electrons or gain electrons? So because calcium is a metal, it's going to lose electrons. And how many electrons will it lose? 2. So I'll just add lost here, 2 valence electrons lost. Okay, so if it loses its 2 valence electrons, all we're going to do is write the symbol for calcium with a little 2+ symbol up above. So that is our calcium ion symbol. And how would we name this ion? So we would just call this a calcium ion. We don't really change its name. Okay, so let's go over chlorine. So is chlorine a metal or a non-metal? It's a non-metal, so it is on the far right of the periodic table. How many valence electrons does chlorine have? 7. We saw that earlier, right? Okay, so does chlorine lose or gain electrons? So remember, nonmetals gain electrons. So chlorine's going to gain how many electrons? 1. So chlorine just has to gain 1 more electron to have 8 valence electrons. Okay, so let's write the symbol for chlorine. So chlorine has 7 valence electrons to start when it's neutral, and it's going to gain 1 more electron to have an octet, or 8 electrons, in its valence shell, and it's going to be negatively charged. So that would be the symbol for a chlorine ion. Although, how would we name the chlorine ion here? So this would be called chloride. So it's a chloride ion. Okay. And then there's also solution slides here if you need that later. So next time, we're going to dive a little bit deeper into ionic compounds. So now that we know more about ions and how they form, next time we'll talk about how metal ions can transfer their electrons to non-metals, and then they form an ionic bond. So I will see you in the next video.